Welcome. Today, we are looking at Organic Chemistry Review. This is a key topic in your chemistry exams for SS3. Pay close attention. Let us begin. First, let me review what organic chemistry is. Organic chemistry is the study of carbon-containing compounds. Carbon is a unique element. It can form 4 covalent bonds. It can bond with other carbon atoms to form long chains and rings. This is called catenation. Carbon can also bond with hydrogen, oxygen, nitrogen, and other elements. This forms a vast number of compounds. Organic compounds are found in all living things. They are also found in fossil fuels, plastics, and many other materials. The unique properties of carbon make it the basis of life and modern industry. Understanding organic chemistry is essential for understanding biology, medicine, and materials science. Now, let me review the classification of organic compounds. Organic compounds are classified into several groups. The first group is hydrocarbons. Hydrocarbons contain only carbon and hydrogen. They are divided into alkanes, alkenes, and alkynes. Alkanes have only single bonds. The general formula is CnH2n+2. Alkanes are saturated hydrocarbons. Alkenes have one or more double bonds. The general formula is CnH2n. Alkynes have one or more triple bonds. The general formula is CnH2n2. Hydrocarbons can also be aromatic. Aromatic hydrocarbons contain a benzene ring. Benzene is the simplest aromatic hydrocarbon. The second group is halogenated compounds. These contain halogens like chlorine, bromine, or fluorine. The third group is alcohols. Alcohols contain the hydroxyl group. The fourth group is aldehydes and ketones. Aldehydes contain the carbonyl group at the end of the chain. Ketones contain the carbonyl group in the middle of the chain. The fifth group is carboxylic acids. Carboxylic acids contain the carboxyl group. The sixth group is esters. Esters are formed from carboxylic acids and alcohols. The seventh group is amines. Amines contain the amino group. The eighth group is amides. Amides are derivatives of carboxylic acids. The classification of organic compounds is based on the functional group. The functional group determines the chemical properties. Now, let me review the nomenclature of organic compounds. The IUPAC system is used to name organic compounds. The name has 3 parts. The root indicates the number of carbon atoms in the longest chain. The suffix indicates the type of compound. The prefix indicates any substituents. For alkanes, the suffix is -ane. For alkenes, the suffix is -ene. For alkynes, the suffix is -wine. For alcohols, the suffix is -ol. For aldehydes, the suffix is -al. For ketones, the suffix is -1. For carboxylic acids, the suffix is -oic acid. For esters, the suffix is -o8. The position of the functional group is indicated by a number. The carbon chain is numbered from the end nearest the functional group. Substituents are named using prefixes like methyl, ethyl, propyl, and so on. The rules for nomenclature are important for identifying and naming organic compounds. Now let me review isomerism. Isomers are compounds with the same molecular formula, but different structures. There are 2 main types of isomerism. Structural isomerism is when the atoms are arranged differently. Structural isomers have different physical and chemical properties. For example, butane has 2 structural isomers. N-butane has a straight chain. Isobutane has a branched chain. Stereoisomerism is when the atoms are arranged in the same order but in different spatial arrangements. Stereoisomers have the same physical and chemical properties. They differ in their effect on plane polarized light. Geometric isomerism is a type of stereoisomerism. It occurs in alkenes. Cis isomers have similar groups on the same side of the double bond. Trans isomers have similar groups on opposite sides. Geometric isomers have different physical properties. Isomerism is important in organic chemistry. It explains the diversity of organic compounds. Now let me review the reactions of alkanes. Alkanes are relatively unreactive. They undergo two main reactions. The first is combustion. Alkanes burn in oxygen to produce carbon dioxide and water. The reaction is exothermic. It releases a large amount of energy. For example, methane burns according to the equation CH4 plus 2O2 equals CO2 plus 2H2O. Combustion is used to generate heat and power. Alkanes are used as fuels. The second is halogenation. Alkanes react with halogens in the presence of ultraviolet light. This is a substitution reaction. A hydrogen atom is replaced by a halogen atom. For example, methane reacts with chlorine to produce chloromethane, dichloromethane, chloroform, and carbon tetrachloride. The reaction proceeds by a free radical mechanism. Halogenation is used to produce halogenated compounds. These compounds are used as solvents, refrigerants, and pesticides. Now let me review the reactions of alkenes. Alkenes are more reactive than alkanes. They undergo addition reactions. The double bond is broken. New atoms are added. The first addition reaction is hydrogenation. Hydrogen is added across the double bond. The alkane is formed. The reaction is catalyzed by a metal. For example, ethene reacts with hydrogen to form ethane. The second addition reaction is halogenation. Halogens are added across the double bond. A dihalogenated compound is formed. For example, ethene reacts with bromine to form 1,2-dibromoethane. The red-brown color of bromine disappears. This is a test for unsaturation. The third addition reaction is hydration. Water is added across the double bond. An alcohol is formed. The reaction is catalyzed by acid. For example, ethene reacts with water to form ethanol. The fourth addition reaction is polymerization. Many small alkene molecules join together to form a large molecule. The polymer is formed. For example, ethene polymerizes to form polyethylene. Now let me review the reactions of alcohols. Alcohols undergo several important reactions. The first is combustion. Alcohols burn in oxygen to produce carbon dioxide and water. The reaction is exothermic. The second is oxidation. Primary alcohols are oxidized to aldehydes and then to carboxylic acids. Secondary alcohols are oxidized to ketones. Tertiary alcohols are not easily oxidized. For example, ethanol is oxidized to ethanol and then to ethanoic acid. The third is esterification. Alcohols react with carboxylic acids to form esters. The reaction is catalyzed by acid. For example, ethanol reacts with ethanoic acid to form ethyl ethanoate and water. Esters have pleasant smells. They are used in perfumes and flavorings. The fourth is dehydration. Alcohols are dehydrated to alkenes. The reaction is catalyzed by acid and heat. For example, ethanol is dehydrated to ethene. Now let me review the reactions of carboxylic acids. Carboxylic acids undergo several important reactions. The first is neutralization. Carboxylic acids react with bases to form salts and water. The second is esterification. Carboxylic acids react with alcohols to form esters. The third is reduction. Carboxylic acids are reduced to primary alcohols. The fourth is decarboxylation. Carboxylic acids lose carbon dioxide when heated with soda lime. For example, ethanoic acid is decarboxylated to methane. Now let me review the reactions of aldehydes and ketones. Aldehydes and ketones undergo addition reactions. They react with hydrogen cyanide to form cyanohydrins. They react with ammonia derivatives to form imines. Aldehydes are easily oxidized to carboxylic acids. Ketones are not easily oxidized. Aldehydes can be distinguished from ketones by Toland's reagent. Aldehydes give a silver mirror. Ketones do not. Aldehydes can also be distinguished by Fehling's solution. Aldehydes give a red precipitate. Ketones do not. Now let me review the polymers. Polymers are large molecules made from many small molecules called monomers. Addition polymers are formed from alkenes. The double bond is broken. The monomers join together. Polyethylene is formed from ethene. Polypropylene is formed from propene. PVC is formed from vinyl chloride. Polystyrene is formed from styrene. Condensation polymers are formed from two different monomers. A small molecule like water is eliminated. Polyesters are formed from a dicarboxylic acid and a diol. Polyamides are formed from a dicarboxylic acid and a diamine. Nylon is a polyamide. Polymers are used in plastics, fibers, and rubbers. They are essential materials in modern life. A common exam question asks you to classify organic compounds by functional group. Here is a sample answer. Alkanes have only single bonds. Alkenes have double bonds. Alkynes have triple bonds. Alcohols have the hydroxyl group. Aldehydes have the carbonyl group at the end of the chain. Ketones have the carbonyl group in the middle. Carboxylic acids have the carboxyl group. Esters have the ester group. Amines have the amino group. The functional group determines the chemical properties. Another exam question asks you to describe the addition reactions of alkenes. Here is your answer. Alkenes undergo addition reactions. The double bond is broken. New atoms are added. Hydrogenation adds hydrogen. Halogenation adds halogens. Hydration adds water. Polymerization joins many molecules. For example, ethene reacts with bromine to form 1,2-dibromoethane. The double bond is broken. The bromine atoms are added. The red-brown color of bromine disappears. This is the bromine test for unsaturation. Another exam question asks you to distinguish between aldehydes and ketones. Here is your answer. Aldehydes have the carbonyl group at the end of the carbon chain. Ketones have the carbonyl group in the middle. Aldehydes are easily oxidized to carboxylic acids. Ketones are not easily oxidized. Aldehydes give a silver mirror with Tollen's reagent. Ketones do not. Aldehydes give a red precipitate with failing solution. Ketones do not. Let me give you a quick summary. Organic chemistry is the study of carbon compounds. Organic compounds are classified by functional group. The IUPAC system is used for nomenclature. Isomerism explains the diversity of organic compounds. Alkanes undergo combustion and halogenation. Alkenes undergo addition reactions. Alcohols undergo combustion, oxidation, esterification, and dehydration. Carboxylic acids undergo neutralization, esterification, reduction, and decarboxylation. Aldehydes and ketones undergo addition reactions. Polymers are large molecules made from monomers. Organic chemistry is essential for understanding life and industry. Practice these concepts. When you have them down, move to topic 8.